All right, so before we get started, let's talk a little bit about acids and bases a little bit more. We talked about the chemistry of it, right? We talked about how acids, they're the ones that give or donate H plus. And then bases are the ones that give up OH minus. Okay, but here are some other properties that they have. Acids, a lot of them are in like fruits and things like that, so they taste a little bit sour. If you have very strong acids, the stuff that we use in labs and stuff, they can melt metal. They basically dissolve metal and create hydrogen gas. Some examples that you guys might know: vinegar, milk, soda, fruit juice, coffee. All that stuff is lightly acidic. It's not like super strong acid. So if you pour vinegar on a metal, it's not going to dissolve it. It's not strong enough. But these are types of some weaker acids. Okay. Bases are things that you might be a little less familiar with. We don't really eat bases very much. They taste bitter though. They feel very slippery. So things like ammonia, lyes, cleaning materials, antacids, baking soda, those are all examples of bases. Okay. No, you don't have to. Just some preliminary information. Okay, so now we're going to get into the actual problems that we're going to be doing for today. So there's going to be multiple parts, just like the previous assignment. So I'm going to keep this up here. If you guys didn't write this down last time, make sure you do. But acids and bases are always on the left side of your equation. They combine to make water, HOH, and a salt. Okay? Yeah, what's up? Yes. That good?
Or what is base?
Yeah, bases, the chemistry of it, they react with water to make water and a salt. Yeah. Okay. All right. So like we said, acids and bases are always on the left side. They react together to make water and the salt. And so I'm gonna give you guys about 3 minutes. I want you guys to work with the person next to you. And I want you guys to finish this reaction. Okay, again, it's the same thing that we've been doing. You want to break up these chemicals into the ions that they're made out of, and then figure out what they're going to make on the right side. Just remember, they're always going to make HOH, so water, and a salt, which is something made out of positive and negative ions. Take about 3 minutes to finish up that equation. If you get to the balancing, great. If not, just do as much as you can. At least try to break these guys up, see what they are made out of, and then we'll go over together in 3 minutes, okay? Okay, so we're going to be finishing up this equation. So first thing you should have noticed is that we have HBr right here. And if you look at the periodic table, H, the MCI is +1. So it's going to break up into H +1. And Br is right here under -1. So this guy right here, this chemical, is going to break down into H plus and Br minus. Okay, so you can use either the periodic table to do that. If you're more comfortable using the solubility chart, this is fine as well. There's no H here, but you got Br. Whatever you like to use, you can use that, okay? All right, we got BaOH2. So if you look on the periodic table, Ba is right here on the +2 column at the very bottom. Okay, so it's going to be Ba2 plus. Okay, so Ba2 plus. And then if you guys remember, OH is always a polyatomic. It's this one right here, hydroxide, OH minus. Okay, easy way to remember it is Mr. O. It's a little bit of a negative person, right? So gonna be negative. All right. Okay, so those are the two ions that these guys each break down into. So we got to do the double replacement. You got to take the positive of one of them. So I'm gonna take the H right here with the negative of the other one. And so if I put H and OH together, is the positive and negative energy going to balance out? Yeah, it's +1 and -1, right? So we can just write HOH. Again, this is water. And then we're going to put these two guys together. Now, if you take a look at these two, are they balanced out, the positive and negative energy? No, it's not, because +2 and -1. So you got to have 2 BRs. You need 2 of these to balance out the Ba. Okay, so keep that in mind. I've been noticing on your labs, I started grading them. A lot of people are still having trouble with the positive and negative energy. So just make sure that you're aware that they do need to balance each other out, okay? Okay, now we're going to balance the actual equation. So we're going to just make sure we have the same number of everything on both sides. If you want to use the table, great. But I'm getting a little tired of drawing the table, so let's just count, okay? So if we take a look here, we got 1H here, 1H here, so that's balanced. We got 1 BR on the left, but we got 2 on the right. So which side needs more BRs? Left side, right? So we're going to put a 2 in front of HBR. That way we can have 2 BRs. Okay, but if we do that, now the H's are not balanced, right? Because there's 1 and 2. So all we got to do is put a 2 right here. And then we have 1 BA on both sides and 2 OHs on both sides. So that's another way that you can balance it. If you're more comfortable doing it like that, feel free to do so. If you like the table, that's fine. But again, there's multiple ways to do it. So do it the way that you're most comfortable. Okay. I'm not going to be requiring you to the table or anything like that. Okay. So that's part A. Any questions on part A? Okay. Let's go to part B. Part B is really easy. Acid and base. I told you the base is probably the easiest one to identify. It's the chemical on the left with OH. So what chemical is your base? Yeah, BaOH2. This is your base. We said acid and base have to be on the left side. So that means obviously the other chemical is an acid. And you can tell because this guy breaks up into H+. And then last but not least, your salt is on the right side, but it's not water because water. So this chemical right here will be your salt. And if you want to label this for your own notes, this is going to be water. And the reason why is because HOH, you can rewrite it as H2O, which we all know is water. All right, so that's part A and B. We're halfway done. Now we just need to go into the math portions and we'll be good. All right, but I'll pause right there. Any questions on acid, base, salt? Okay. All right, let's move on to part C. Part C is where we need to write the procedures. Okay, we learned this at the end of last unit and you guys had to do it for the lab. And I noticed a lot of people had trouble with this part of the problem. So we're going to be continuing to do it. Okay, so what you want to do when you write the procedures is you want to have these 5 steps, and I'll always have these available to you in your notes. And so you don't need to memorize them, but you just need to know how to fill in the blanks, okay? So whenever you're trying to make a solution, you're trying to make a liquid with chemicals dissolved in it. Step 1, you want to get a certain size volumetric flask. It's the thing with the skinny neck and the kind of big bottom. Looks like this. We use it in the lab. Okay, and then the size that you want is the exact size of the solution you want to make. So if we want to make 250, we need to get a 250 ml volumetric flask. Okay, so that's step 1. Super easy. You want to get a 250 ml volumetric flask. And obviously, if this was like 400, then you would want a 400 milliliter flask. 1,000, you want 1,000, so on and so forth. Okay. Okay, step 2, you want to weigh out grams of the chemical you're trying to make. So HBr, we're trying to make an HBr solution. And so we got to weigh out how many grams of HBr we need. Now, we don't have grams right now in our problem. So we got to take these numbers right here and turn it into grams of HBr. So step 1, we're going to use the molarity equation, which is moles divided by liters. And then we're just going to plug these numbers in. So I'm going to give you guys a minute. See if you guys can get the numbers that we start with right here. And see if you guys can plug it into the molarity equation and find the moles of the chemical you're looking for. Okay. And if you want to go on to step 2 where you turn moles into grams, go ahead and try it. But at least for the next minute, see if you guys can take these numbers and find moles of HBr. Okay, so take about a minute to do that. Okay, so what we're going to do is we're going to take the numbers that we have right here and plug it into this equation. Super simple. So the number for molarity is 0.5. So we're just going to plug in 0.5 into our equation right here. So 0.5 molarity. We're looking for moles, so we'll leave that alone. We don't have liters, but we have milliliters. And if you guys remember, you just divide it by 1,000. And that's going to give you your liters. So this is going to turn into 0.25 liters. So we'll put 0.25 on the bottom. All right, so easiest way to remember how to do this is you want to just multiply both sides by the number on the bottom. So multiply both sides by 0.25. And the reason why is so that we can get rid of this. We only have moles left on the left side. And then all we got to do is just punch this into our calculator. So if you guys have your calculators, you guys should have punched in 0.25 times 0.5, and that'll give you 0.125. Okay, so 0.125 is going to be your moles of HBr. All right, any questions on that first calculation? Okay. Next, what we're going to do is we're going to take the number that we got from step 1, and then we're going to just turn it into grams. And this part's really easy. We just start by writing down the number we just got, 0.125 moles of HBr. Okay, we're going to set up one fraction. We're going to get rid of moles and turn it into grams. And we're going to get this using the molar mass. So what you're going to do is you're going to go on the periodic table, and then you're just going to look at the numbers on the bottom for each element, okay? And that's going to allow you to find the molar mass of this chemical, okay? So let's take a look at your periodic table. So if you guys have it with you, you guys can pull that out. But HBr is made out of H and Br. So let's take a look at H first. So if you take a look at H on the periodic table, what's the molar mass of H? Yeah, 1.01. So we got 1.01. And then what's the molar mass of Br? Yeah, 79.9. So all we got to do is on our calculator, add those up. So 79.9 plus 1.01. That's going to give you this number right here. And this is the molar mass of HBr. So all we got to do is go back to our calculations and just plug this into our fraction. So 80.91 is going to be your molar mass. And so all we got to do is multiply these two numbers, and that's going to give you the grams of HBr that you need. So you need 10.11 grams of HBr. Okay. Okay, so just to clarify, you just take your moles number, 0.125 right here. You multiply it by 80.91 because it's on the top of the fraction. Okay. And then that's your answer. 10.11. I rounded to two numbers. If you want to round to 3, that's fine as well. As long as you got something around there. Okay. And then the last blank right here for step 3, you just need to transfer your chemical HBr to the volumetric flask. So that's part C. And then we just got one part left, and then we're all done. Alrighty. Any questions on part C? Alrighty. Okay, let's move on to the last part. Now, one thing before we move on is I want you guys to put a box around this number right here somewhere on your notes. Okay, 0.125 moles of HBr. And the reason why is because for part D, the stoichiometry, this is the first step, but we already did it. So you can actually just jump straight in to the stoichiometry. You don't need to redo step 1. Okay, so just put a box around this so that you remember that this number is important, 0.125 moles. Okay, because we can start the stoich with just this number right here. Okay, so that's my little hint for you guys. As you guys do your assignment, you can just start with your moles from part C. Okay, don't double up your work. All right, let's move on. Okay, so you don't need to copy this equation down right here either. And you guys don't need to write this number down. I'm just going to put it down for our reference. Okay, but what we're going to be doing is we're going to be taking all the info that we got, and we're going to figure out basically how much salt is created. So the first thing we want to do is we want to figure out our starting number, okay, what our starting number is, and whatever we want to end with. Okay, so if you take a look at the problem, it says that you're going to react HBr that you made in part C with excess BaOH2. So just by looking at that, what chemical is our starting chemical? Yeah, HBr. That's the thing that you're going to be working with. So our starting number is just going to be 0.125 moles of HBr. Okay, and then for the ending, it's asking you how many grams of salt you want to make. So out of these 4 chemicals, which one is your salt? Yeah, BaBr2. We did this in part B. So yeah, all that stuff we did is coming back together, and then we're just finishing up with the calculation. So we want to end up with BaBr2. Okay, so we're just putting everything together now. Okay, so what we're gonna do is we're gonna take our starting number, 0.125 moles of HBr. And then what we're gonna do is we're gonna set up two fractions. So I'll give you guys a second to copy this down before we move on with more explanation. But you're gonna have two fractions, and then I'm gonna start labeling the fractions for you, and then you guys can fill this stuff in, okay? So this is what you should copy down. And we'll take a little pause right now. Just make sure that you guys have enough space on your fractions to write stuff, because as you guys know, we're gonna put numbers and stuff in it. But take about a minute to copy this down. If you want to try plugging stuff in, feel free to go ahead. But I'll take a pause and then we'll fill it in together. Okay, so what we want to do is we want to start filling in everything on this fraction. Now, I told you guys easy trick to kind of get things correct. The tops of these two fractions right here at the end, it's always going to be about your ending chemical. Okay, you guys might have noticed I color-coded it just to kind of help you guys out. But these two fractions are always going to be about this ending chemical right here. So if you guys don't know what to plug in, just kind of write these here, and that'll kind of help you guide you on your way, okay? All right, this second fraction right here, we're going to get the numbers from the balanced equation. So all we got to do is look at the numbers in front of the chemicals on the balanced equation. The bottom number will always be your starting chemical, so HBr. So let's find the numbers on the equation. So what number is in front of BaBr2? Yeah, just 1. There's nothing, which means it's 1. So we put a 1 right here. Okay, what number's in front of HBr? 2. Yeah, just right there. So we're done with that fraction. And then for the last fraction, we're going to get the numbers from the molar mass, okay, of BaBr2. So same thing. We're going to go on the periodic table, look at Ba, Br, add it all together. The number on the bottom is always 1. So whatever number you get, you put on the top. So I'm going to give you guys about 3 minutes to finish up this problem. See if you can get the final answer on your own. Just remember the rules for the multiply or for the calculations is multiply everything on the top. All the numbers on the bottom, you're going to divide. Just remember there's a number on the bottom here, so be careful of that. And then you're going to ignore all the ones. Okay, so those are the 3 rules for the calculator. I'll give you guys about maybe 2 minutes to see if you can finish up that problem. You just need to find the molar mass right here, punch it into your calculator, and let's see if you guys can get the final answer on your own. Take about 2 minutes to do that, and then we'll go over it. Okay, so our starting number 0.125. We're going to multiply everything on the top and divide by the numbers on the bottom and ignore the 1. So we got a 1 here, so we can ignore it. There's a 2 on the bottom, so we can divide it by 2. So divide by 2. And then we got 297.13 on the top. So we multiply by 297.13, and you'll get a final answer of 18.57. So if you got something close to that on your own, great job. That's exactly what you were supposed to do. You should be pretty good with using the calculator. And so that is going to be our final answer. Our final answer is 18.57. If you put 18.56, 18.5, something close to that, you're good. As long as it's around 18.5 grams of BaBr2. Okay? Alrighty, and that's pretty much it for neutralization stoich. We'll spend today practicing that. That's going to be on your assignment. And next class, we'll be practicing this a bit more, and then we'll be moving on to kind of the more, I guess, difficult, tricky stuff for this unit.